R is one of the most comprehensive statistical. So R is nothing but mainly used for the statistical purpose, and also it is one of the high level language. Whatever the code will contains any data types or the history will be displayed here. So that's why history and also environment. Got it? So every language has its own data types. Likewise R has its own data types. So these are all the basic and also important data types. Hello students, this is Asha, Faculty of Computer Science at Vidhyaashram First Grade Degree College, the Temple of Excellence, MYSURU. So in the last session, we already get to know what exactly the syllabus and what are all the syllabus contents. So let's welcome to the today's session. In today's session, we are going to explain about the Unit 1, that is Introduction of the R Programming. What do you mean by Introduction of R Programming is nothing but so what are all the data types or features? These are all some important topics. So let's discuss. So here you can see in today's session we can cover the introduction and also features of R programming, data types and also data structures of the R programming. So let's see one by one. So here you can see the introduction of R program is nothing but R is one of the most comprehensive statistical. So R is nothing but mainly used for the statistical purpose, and also it is one of the high level language. So why we call high level language? Because it's a human readable formats, or what are all the English language. So we are also called, this is also called high level language. So that's why it's a statistical programming language and also capable of handling everything from data manipulation and also visualization. This is the most important definition of the R programming. R program is nothing but a high level language which is used for the mainly statistical purpose and also some visual data representation in a visual format. So that's why R is one of the most comprehensive programming language. So R is widely used in so who are all used R is data scientist, and also here you can see statistician and data miners, data for analysis, for the data analysis. So what do you mean by data analysis? For example, you have data called first year, second year students. So I have to analyze. Without the visual representation, I can't analyze the data, right? So that's why data analysis is the most important. So who introduced the R? Introduced R by who? Raz Ihaka and also the biostatistician, that is Robert Gentleman. So here you can see the name, the author's name start with the RR, right? So that's why they named this programming language as a R programming language. Got it? So here you can see the author's name Raz Ihaka and also Robert Gentleman. So this is the R icon. So this is the R icon you can see. So here you can see what are the features. So every language has its own features, right? So that's why R has its own features. So here you can see comprehensive statistical analysis. So statistics is nothing but data analysis. For example, if a data points is there, I have to analyze the mean, median, mode and also some statistic analysis. We can use the R as a statistical analysis. So R is almost similar like a Python. In Python is also one of the high level language because it uses a high level language. Why? Because we can represent the data in a visual format than the theory format we can represent. So here you can see, and also the second feature is advanced data visualization. So I have to visualize the data through the theory or as the data points I can visualize graphically. So that's why R is one of the advanced data visualization technique. So in visualization we can also see a bar plot, pie plot and also box plot and scatter. These are all some important graphical representation. And the next one is extensive packages and library. So CRAN is the software. So CRAN is nothing but CRAN is the software, is main software. So comprehensive R Achieve network. So CRAN is nothing but a comprehensive R Achieve network. So it contains a lots of libraries. So for example, library called derive. For derivative functions we can see. So likewise we have inbuilt derivations and also inbuilt functions and lots of library for the data manipulation purpose. So that's why R provides the extensive packages and also what? libraries. Got it? And the fourth one is open source and free. So R is not a paid like a MATLAB. So it is a open source. We can run on any system or any operating system, and also we can easily download from the Chrome and also Google. So that's why, and is a open source and also free. No need to paid. So here you can see the platform independent. So platform independent means we can run. It doesn't depending on any one operating system, because it can depending on any other system. So any other operating system. So we can run R in a what? Windows, Unix, and also Linux, and also Mac OS. So that's why it's a platform independent. So not a dependent. Dependent is nothing but it runs only on Windows. It runs only on the Mac. It runs only on the Unix software. So not like that. R is a platform independent. Platform independent means it depends on the platform, means it runs on any operating system. So that's why platform independent. So integration with the other languages. So integration with other languages, we can integrate with the other languages means other programming language like a C++ and also Python. These are all the most familiar syntax look like. So our syntax will be looks like similar with the like most similar or most similarity in the C++ and also what? Python. So it almost similar to the Python and also C++. So that's why we can integration with the what? Other languages or also other programming languages. So let's see the last high level language. So high level language, low level language, these are the computer languages, right? As a human being, we have to understand the computer by some codes. So then only the computer will do the task, right? So high level language is nothing but if, for example, if I say hello world to my computer, so when we write hello world in a normal English, it will accept, but computer reads like a binary bits, that is 10010, right? But when I write source code as a 100, we can't. As a human being, I can't understand anything. But when we can understand hello world, what exactly the hello world is a normal English word, right? So that's why it can understand. So that is understand by the what? R programming language. So it will interpret to the what? Computer. So that's why R is one of the high level language, and also it is a interpreter language. Interpreter language. So why we called interpreter language? Why? Because each line of the code it will be executed. So in the R studio or the R console. So that's why it's a interpreted language, line by line, not a whole program like a C or as a C++. So it will be interpreted language. Each line will be executed at once. If any one line contains any error, it will be debugged by the users. So that's why R is one of the interpreted language. These are some main what? Features of the R programming. Got it? So let's see. So here you can see R program will be run on R Studio. This is called R Studio window. So when you open the R Studio, you will get a file, edit, code, view, plot, session, and also build, debug. So when you open the R Studio software to do a R codes, so here you can see it will looks like a 4 partitions. 4 partitions. Got 4 partitions. In the first partition, you will get a R script. So R script is nothing but a whatever the code or the whatever the source code by the user they can enter, or data scientist or the users they can type here in the R script. So come to the second, this is the R environment. R environment is nothing but a whatever the code will contains any data types or else the history will be displayed here. So that's why history and also environment. Got it? So and also third window. So whatever the program, after running the program, you will get an output, right? The output will be displayed here. What? R console. So we can also, it also run like a R command. So command prompt, like a normal system command prompt. We can also type a program and run here also. But for the friendly user, you can use a R script to write any program. The output will be displayed in a R console. Got it? And the fourth window, As I already told, R provides a graphical representation of any data, right? So graphical representation means we can use a plot. Plot is nothing but it's also an inbuilt function which provided by the R to do easier tasks. So whatever if my data will be contained, if the code will contain any graphical representation, after running it will visualize the graphical representation. These are all the 4 partitions, mainly 4 partitions in RStudio. Got it. So let's see. So here you can see data types. So every language has its own data types. Likewise, R has its own data types. So these are all the basic and also important data types. So data types is nothing but whatever the data. So for example, if a data contains only numbers, it will belongs to numbers. If the data contains only logical, like a true and also false, it belongs to logical. Likewise, R provides basic data types. In R can divide the following types. The first one numeric, integer and complex, and also what character and also logical. So what do you mean by numeric? Numeric is nothing but a 10.5 likewise. So for example, 2, 3, this is also in other programming language we call without the fraction point. Means 2 we also called as a what? Integer, right? But here 55 is also a numeric, not an integer. 787 is also numeric, not an integer. And also 10.5 is not a floating point. This is also called what? Numeric. But then what is the difference between the numeric and also integer? How to find out the integer values in R programming? Yes, we can also find out the integer. How? L. L is nothing but a long. So in some other sources, they didn't mention any what exactly the mean of L, but you have to mention the suffix. Means after the value you have to mention the suffix value called capital L. Then only R console or R interpreter will read as this as a integer, not a numeric. Got it now? So here you can see, if I mention 2.2 L, it will be not a numeric and also floating. It will be read as a integer data type, not a numeric floating. So come to the complex. It contains a what? I is the imaginary part and also 9 is integer. And also character. So character is nothing but as known as string. So group of a string within a double quotes is also called character or string. So here you can see we can also convert number into the character how within the double quotes. So here you can see logical. Logical is nothing but Boolean expression, that is true and false. So let's see one by one in detail. The first one is numeric data type. Represent numbers including both integers and also floating point. As I already told, it read a normal integer and also floating points. It called a what? Numeric data type. So here you can see one example. I declare a num1 and also num2. The num1 carries 10. In here num2, that is 10.5 only. But when I print means using the print function num1 and num2, what the output? The first one 10 and also second one is 10.5. Got it now? So in R we can also declare 2 plus 3 without the explicitly declaration of the data type. In other programming language like a C, I have to declare like a int a comma b comma sum, right? Put a semicolon here. And also for sum is equal to a plus b. And also I have to put a what do you mean by a is equal to 2, b is equal to what? 3. Like how we have to declare in other programming languages, right? But here in R, we didn't mention any data type explicitly because it read implicitly by itself. So here you can see num1 is 10, num2 is 10.5. So directly the output will be 10 and 10.5. When I run this 2 plus 3 without any explicitly defined of a data type, it will give a result as what? 5. No need to explicitly define the data types. And R is also a case sensitive. What do you mean by case sensitive? So for example, if I assign a variable name called sum with a capital letter S, if I call that sum with a small letter sum, it will pop up with an error. Why? Because it is case sensitive. Here it will compare the variable name. Here S is capital, here S is small. So that's why it will pop up with the error. So that is what case sensitive. Got it? So let's see another what data type, that is integer, specifically represent the integer values. So here you can see one example, on small example. I assign a integer. This is my variable name which contains what? 3. 3 with the what? Capital L. That is what? Differentiate between the numeric and also integer. So when I use print function, I assign a int variable name. It gives a what? Output as a 3. Got it now? So here you can see the next one is character, represent text strings. Here you can see example. I call a variable name called char underscore val within a double quotes hello r. When I using the print function, I can print the variable name called what? Output hello r. So let's see another one. So here you can see what? Logical. So logical is nothing but represent a boolean values, only true and also false. So I assign a variable name called a true. When I use print function bool value, it got a output like a true, because variable name contains only true possibilities. So that's why the output will be true. The next one is complex. Represent a complex numbers with real and also imaginary part, which contains 2 parts, that is real and also imaginary part. So when I declare 2 plus 3i, if a number contains only 2, not a 3i, so it will pop up with error. So that's why 2 plus 3i, when I using the print statement, I can assign the variable name complement, that is complex number value. I got a output like a 2 plus 3i. Got it? This is how you have to define a data types in R programming. These 5 are the main data types available in a R programming. Got it? So let's see data structures. So here you can see data structure. Data structures is nothing but the way of storing or organizing the file to access or to manipulate the data will be known as a what? Data structure. So R provides mainly 6 data structures. These are the vector and also matrix, list, data frame and also array. So in array and also list and also matrix, these are all common in also other programming language like Python, C++. But data frame and also vector, these are all 2 new topics in R programming. Why? Because R provides only these 5 main data structures in R. So let's see one by one. So here you can see the first one is vector. So vector is nothing but a vector is ordered collection, not a unordered. So you have to remember the point. A vector is a ordered collection. So which types given a length. The only key thing here is elements of vector must be identical. So the elements of the vector should be identical, not a non-identical. Then only the vector should declare a value. So here you can see the one example, the illustration of vector in R. So here you can see why C here, because we have to concatenate more than 2 elements into one single vector. So that's why we need a C here. Without a C, when you mention within a bracket 1, 2, 3, 4, 5, it will pop up with the error. So that's why use a C. So after printing this x variable contains a numerical vector. So that's why the output will be what? 1, 3, 5, 7, 8. So for example, if a vector contains x is equal to what? Only characters like a, B and also C. This is also acceptable. When I print, I got a, B, C as a character vector. So this is numerical vector because it contains only the numbers, not a numbers with the characters. So the vector should be identical. All the elements of the vector should be same type. Got it? The second one is data frame. So data frame are generic data objects which are used to store tabular data. So tabular data is nothing but in a like a matrix form, rows and also columns format. So data frame are the foremost objects in the R programming because it's a seeing the data within the tabular form. They are 2-dimensional heterogeneous data structure. So it's not a homogeneous. We can also define a heterogeneous means which contains a varieties of data, not only a single type of data. It can contains a character, number, strings, like that. It contains a heterogeneous data. So here you can see the following constraint placed upon them. While we declare the data frame, we have to follow some rules, right? So the first one says A data frame must have column names and every rows should have a unique name. Every rows have a unique name. So each column must have their own identical number of items. Each item in a single column must be same data type, and also different columns may have different data types. So to create a data frame, we have to call a function name, the inbuilt function name what? Data frame. So here you can see data dot frame, open and close parenthesis, then only the function will be valid for accepting the data frame function. So let's see one example. Through the example, you can understand what exactly the data frame. So here you can see a vector which has a character value. This is a program to define a data frame, to illustrate a data frame. So name. So I already use a name variable C of Amiya, Raj and Ashish, and vector of language, another one variable language which contains the languages names, and the last one age which contains the ages only. So when I create a data frame, use data.frame as a command or the function, and then pass each of the vectors. What each of the vectors? Age and also language and also name. Got it? So then to the function of data frame, and also when I use df is a variable name, after ds put a left forward sign or is equal to sign, call the data.frame, that is the function name. We have to pass the parameters into the function, right? So that's why data.frame within a bracket call name, here name, and also language and also age. So after printing df, you will get a result like a what? Output statement like a this. Got it now? This is the output. The data frame name, data frame language and data frame age with the rows 1, 2, 3 and also with the columns name, language, age. This is how frame wise or the tabular format the data will be stored. So that's why this is called a data frame. So let's see another one. So here you can see the matrix. So our matrices. A matrix is a rectangular arrangement of numbers in rows and columns. In a matrix, as we know, rows are the ones that run horizontally and columns are the one which runs vertically. Matrix are two-dimensional and also homogeneous, and also data structures of the homogeneous. So matrix should be have homogeneous types only, not the heterogeneous. So here you can see one illustrate an example of the matrix. So here you can see when I declare a matrix, I have to call a matrix function. For the list also, for the array also, we have to declare a function only, then only it will be valid. So when I assign matrix to the variable called A, so with the values called with a C, 1, 2, 3 up to what? 9. So again, n row is equal to 3, n column is equal to 3. So by the R console, when I not define the n col is equal to 3, by default the element should be arranged in a column, means vertically, not a horizontally. But I already declared n col, and also by default matrices are in a column wise, as I already told. So no need to declare by col is equal to true. No need this. Got it? By row is equal to true means it will, the element should be filled up in a row wise, not a column wise. Got it? So when I close this matrix, call the function print and assign the variable. So variable A contains what? Matrix element. So here you can see the data will be organized in a what? First row, second row, third row. Because I already give a what? N row is equal to 3, n col means 3 columns and also 3 rows, right? So that's why the element should be filled up in a column wise. By default, the element should be filled up in a column wise, because I have to give a by row is equal to true. So when I give a by row, by col is equal to true, the data will be organized in a what? Column wise. This is how you have to give the matrix. So let's discuss about another one, data structure, that is what? Arrays. Arrays are the data objects which stores the data in more than 2 dimensions. Array are n-dimensional data structures. We can store n number of varieties of data, and also, so for example, here you can see, you can create a array of dimension 2, 3, 3. So what exactly the 2 comma 3 comma 3? Here you can see then it will be creates 3 rectangular matrices each with 2 rows and 3 columns. So 2 rows, 3 columns and also 3 dimensions. So here you can see one example of the illustration of one-dimensional arrays. So this array is my variable name, and also when I call C of 1 is to 24. This is called range. Up to from the first element we have to organize up to 24 elements. So when I use a colon here, this is symbolized as a what? A range or the sequence. So when I call this array, it will be printed as what? Multi-array. And also when I call the array function, this array comma dimension of 4 comma 3 comma 2 means 4 rows, 3 columns and also 2 dimensions. Dimension 1 contains the 12 elements. Dimension 2 contains what? 12 elements. This is how you have to print the arrays. Got it? So here you can see the output of this example. The first dimension 1 which contains what? The elements 4 rows and also 3 columns. It's already defined by here. 4 rows, 3 columns and 2 dimension. Dimension 1 which contains only up to 12 elements. Dimension 2 which contains only 24 elements. So up to 24 elements should be stored in a 2 dimension using the arrays. So let's see the another one example. What? The last one is list. So here you can see list is the last type of the data structure. So a list is a generic object consisting of ordered collection of objects. Again, list is also homogeneous and also ordered collection of the objects. Lists are heterogeneous data structures. These are also one-dimensional data structures. And list can be a list of vectors, list of matrices and also a list characters. Or list can be a heterogeneous type of data structure. So here you can see one illustration example of the list. So which contains the employee ID. Employee ID could be in a numbers, right? So that's why using a C function 1, 2, 3, 4 employee names and also numbers of employee 4 and also employee list. We have to use a list now. So call the list function. We have to call the list function. So all functions are case sensitive. We have to use the small letters only, not the capital letters. So within the list only we have to pass the parameters here. So that's why employee ID we already declared and employee name and also number of employees. So when I call the print statement using the variable called employee list, in the employee list all the variables should be there. So when I give the printing statement with the variable name called employee list, I got the output like this is the first list. The list should be in a first, that is 1, 2, 3, 4. Second list, that is AB, Sandeep, Subhan and Shiba. So this is how the list will be printed. And lastly the third list. The third list shows a number of employees. This is how the list will be worked because this is a heterogeneous data structures. These are all the most important data structures available in R. Thank you.